Good evening, everyone. Silicon Valley is happy to welcome you all to today's event. I encourage you to be active, ask questions, and engage. Your participation is what makes event like this truly valuable. We're especially pleased to welcome our speaker today, Olga. Thank you so much for being with us. We truly appreciate your presence and expertise. And let's make this session productive and inspiring for everyone.
So, should we wait another minute?
Okay, let's wait for a couple of minutes.
So I think we can start now. Hi, everybody. My name is Olga, and I work at Yandex as a data scientist. And today I would like to present you my presentation, our workshop, and the main discussion of this workshop would be building a model from scratch, the cold start problem. So basically, we will talk about how to design your approach to build a model. And after some theory, we will talk about some examples based on my work experience. And I hope that you will give me your guesses how to solve this problem. How to solve this problem based on theory we discussed before. So there is no such thing as like bad questions or bad ideas. So after this discussion, I will give you my example, what we did in the past to solve this problem. But maybe your ideas would be even better than our approach. So as a start, I would like to remind you about common ML tasks. So what we have as a common ML task, we have here like classification problem. Classification problem is a problem when we try to predict if an observation is part of one class or not. And the part of this problem, we could try to predict not one class, but several classes. Or maybe it will be kind of multi-label problem, multi-class problem. For example, here we can try to determine people with illnesses from the rest of the people, or we're trying to find out which people will buy TVs, for example. So it's a classification problem. And after that, we have like regression problem, these problems with continuous target, when we try and predict not binary classification, but continuous target, for example, prices, time, something like that, churn, for example. And also we have kinds of unsupervised ML problem. It's, for example, clustering. So basically, it's when we trying to divide our audience into clusters and get some information about this audience. And mostly it's not like it's not the problem by itself, but this ML task could give you some more information about your database. So it's kind of like recommendation here. And after that, we have like ranking problem. Basically, it's you can see it, when you are trying to make a search request, for example. on your browser, you're trying to find some apps, for example, sites, and the relevance of this display, it's like ranking problem. And last but not least, we have like a recommendation system here, and you can see it at Netflix, Spotify, or even like spam advertisement on your email. So it's commonly recommendation system problems. So what's going on in real life? So types of challenges we face in real projects. So basically we have like two options here. So first option, when we don't have a task, when we already have like some previous approach, somebody solved a problem before, and we need to improve this system. So maybe it's not relevant any longer. For example, maybe there is some subset of clients and the model never saw it before, and we need to add this subset of clients. Or maybe some feature, it was good before, but now it's not so good, it become lousy and noisy, stuff like that. Or maybe we just want to take this solution as a baseline and build more profound model based on this solution. And so what we have here, it's like maintaining and improving accuracy of existing model and adapting models to handle new data efficiently. So here, mostly we have like enough information, and we just need to bring a better solution here. And another type of task, it's when we're trying to build a solution from scratch. So here we have full development cycle from data collection to model deployment. And in my opinion, it's the most interesting part. However, we face some challenges here. I think you can guess which challenges we have here. So the challenge is we have no data, like at all. We have no features, we have no target, we have no valid hypothesis. So we have no information, and we need to gather this information somehow. And when we speak about features, mostly it's not so difficult. So any company, it has some data, and we need, like, of course, we need to like gather it, to combine it, something to do something with that, so to clean it, prepare it, but there are data. And we need to extract some feature, and it's like doable. So it's possible to get some features to build a model. But when we talk about targets, sometimes it's like a really difficult task, because, for example, you can get only few observations here. So, for example, you have a target with 100 observation, and it's too small to build a model and to verify it, you know. So you need to deal with this target somehow. And as an example of this cold start problem, it's when you like trying to implement new project and you don't have any information about this particular project and about the way people like to buy it or not, because it's new. Or even if it's like an old project, maybe you don't have enough data. So what we can do in this case? There are several strategies to mitigate cold start, to mitigate this problem. And the first thing to do is like literally ask your colleagues. So it could sound silly, but communication is still the key. And in big corporations or in small corporations, sometimes people don't have like this online source with shared information, and you need to go by your legs to the people and ask them about this problem, to communicate, because sometimes they have like similar tasks with similar problem, and you can take some approach or information from these tasks. And sometimes they can give you some advice how you can gather information or how you can get more targets to your task. If you don't have enough information by asking it to colleagues, you can Google some solution, and sometimes it's really there are really great pipelines online. Mostly when we talk about LLMs, about large language models, or when we talk about some chats and advisors, you can Google some great solution and try to change it a little bit and try to implement it based on your realities. So after that, you can think about data collection. For example, you can add rewards for users to encourage them to write reviews here, or you can ask your colleagues to determine a little bit more target to you, to label it a little bit more. When we're talking about this strategy, sometimes you can help here your colleagues or assessors, and you can divide your database into smaller parts and try to label the part with a higher probability of positive target, because positive target is more, it's better for you than negative target, so it's better information, and so you can bring a smart approach here. So what else we can do with this cold start problem? There is an approach as a model initialization here. So basically, it's about using pre-trained models. So we can talk here about like online pre-trained models, or some pre-trained models in your company, for example. So, and also we can use here as like train model on a different target and a little bit adapted to your actual target here. And also you can use pre-trained word embedded here also. And this approach is really great for LLMs, for some visual recognition. So when we talk about nets here, we can unfold some layers, like add your subsample here, and it will be a great model. So you don't need a lot of target in this approach. And of course, what can we do next? We can generate some data. This approach, it's not the best way to solve like binary problems, because you don't add like extra information when we talk about like binary target. But when we talk about some visualization or even like text models, it's like good way to generate synthetic data set, because there are a lot of libraries which can provide you like good picks, for example, and it will help your future model. So there are another approaches here also, and basically these approaches like active learning and working with Elkanota method, it's kind of two iterative process. So it's basically what we discussed here is basically two steps modeling. So on the first step, when we talk about active learning, on the first step, we are trying to predict positive class. And after that, we will pick only those observations where the model isn't really sure about its verdict. And we will build another model to help it. And the theory is that, like in this case, the model will bring you better solution about this uncertainty. So as an example here, we have like using active learning and spam detection by selling emails, by selecting emails with high uncertainty scores for manual labeling, and iteratively training a model to classify customer feedback on examples with highest prediction entropy. So this is active learning. And also we have like another method, it's Elkanota method. And this method based on conditional probability. So here we have a thesis that we know how much targets we have in our database. So basically here we have a hypothesis that we have, for example, 10% of sick people from all the people. And but we, you know, the label data, the marked data is only like 1%. And we built a first model, and this model give us some score. And we tell something like this score, like the observation with high score, now it's not like unknown observations, it's positive class. And then we take this observation as a positive class and build another model about this model, which will give us some results. And when we talk about these approaches, I think that the better way is to split features from one model and to another model. So I think that the better way is to use different dimensions and different features. For example, if we talk about loyal customers, so we have some features like gender, like age, and other stuff like that they sent us in the survey. And we can use this info to build our first model. And also we have some transactional data, so about purchases in the past, about like activity, about luxury segments, stuff like that. And we can use this kind of information in our second model. So to divide like a first model from the second model and to gather like more information here. So I think that's all what I wanted to tell in theory part. And now we can discuss some real problems based on my work experience, which we solved in the past. And I hope that you will give me your guesses how to solve this problem. And I think that some guesses will be better than our solution. So let's do that. The first problem is falsification of financial statements. So what we have here, description: companies submit financial statements once a quarter, and sometimes there's fraud in them, and we want to catch this fraud in advance. And which problems we have here? So we have low frequency events, we don't have enough data, and we have, it's really difficult to determine falsification. So basically, we needed approximately 3 weeks to be sure that the company, that these statements is fraud statements. So it's really difficult to prove actual fraud here. And so I will paraphrase the situation here. So again, what we have here, companies give out some financial statements, and we want to be sure if these statements are true or not, because when we catch fraud, it will bring a lot of problems with money. So what do you think? What can we do here? Maybe Oh, wonderful. Search for another signal. Yeah, so actually it's what we did. So we found another signal. So it's wonderful, guys. We found another signal based on our database, which were correlated with that fraud statements. And it was a signal about internal credibility of the company, and when this internal credibility it drops drastically, it leads to these fraud events mostly. So we built a model based on this correlated target, and we we verify our model on this data set of actual target that we have here. And another challenge in this case was to verify if the model is good or not, because as I told you before, it's pretty difficult to determine its falsification 3 weeks, and we couldn't wait for 3 weeks to be sure that our model is working. So we make a survey with some questions to project managers, and they answered and the question was like, what do you think? Is it good financial statement, or maybe there is some anomalies here? So maybe you can tell us that something strange happening here. And it was really important to put this question this way, because when we asked directly, do you think it's a fraud or not, they answered almost always not, because if they would answer if they will give positive answer, it will be the result will be that their work is not good enough, so it's their mistake. So it's better to paraphrase these phrases here. So let's go to another example here. Robot detection. So description here, part of the traffic that comes to us comes from robots, and we want to leave only organic traffic. And the problems here, who are robots? Robots are evolving, and what can we do to detect this robotic traffic? So I would like to add why the robotic traffic is bad. It's because it's impossible to bring some good information from robotic traffic. So if we talk about advertisement, for example, robot can make an illusion of activity, but they won't buy a real product. So therefore, it's really important to split it from organic traffic, and like robot couldn't give you any information about real demand. So what do you think? How can we detect robot here? Yeah, wonderful. You got to detect some anomaly. You're supposed to detect irregularities. So yeah, it's one approach. You can try to find some anomalies in traffic, trying to find some rules here. Also, you can, if you have a signal like complaints, for example, you can use this signal, and also to prove your theory here, you can generate your old robots. So if you're trying to protect your final user from this robotic traffic, you can try to generate your robots and see if these robots could pass your security system or not. But as we told, as I was talking before, robots are evolving, so it's like a really difficult problem to catch all robotic events. So it's like you're always searching for new ways to find robots. So And we have like another example here. It's about bad advertising traffic. And description here, there are advertising platforms, and they have advertising traffic of different quality. And intuitively, assessors understand which traffic is bad and which is good, but there is no methodology, and we want to create a metric that would show the quality on the platform. And what problems we have here, what is quality of advertising traffic, and how to measure that. And what I want to add in this case. So you have a lot of metrics which correlated to the traffic quality. So it's like metrics somehow connected with money, with eventual money, or some, if we talk about robots before, it's some metrics about like true click, or about like final conversions, but it's like a lot of metrics. And we have, for example, a situation with two apps, and on one app we have like higher revenue and higher percentage of robots, and on the other app we have like lower revenue but lower percentage of robots, and how you can compare these like two apps. So what we can do here in this case. Your guesses, maybe on the chat. Yeah, combine them into quality score can help assess traffic performance on each platform. Actually, it's part of the solution here. So firstly, we need to get a subset of labeled data. So we need to understand which platforms is good, which is typical, which is bad. And what we did, we split it using clustering mechanism, using anomalies mechanism, and using also complaints from our final users. We split it our database to like some clusters, and we take, so we can define a set of metrics that reflect traffic quality, like conversion rate, bonus rate, blah, 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 and combine it into, yeah. So firstly, we like, it's needed to create an actual data set on which we can prove our theory here. And so again, we split it out database into clusters. We get some anomalies here. We get like some signals as complaints. And after that preparation, and after we gave all these pages to assessors, we had some understanding of which apps good, which is bad, which is typical, but still it's really, it's a process which makes a lot of expenses, and it's still few observations. So we couldn't use this data set as a data set to build a model, but we could use this data set as a data set to verify the model and to verify our hypothesis. So after that, we combined, we gather all these features, metrics reflect traffic quality, as you guessed, like in the chat, and from them, so we transfer it to one direction and combined it to one feature, one quality metric, and verify it based on our data set with labeled data. What is important here, important part here is that when we talk about this algorithm, we talk about unsupervised modeling here. So because of that, when we leave a model like this, it could be biased in the future. So it's really important to think about it and to balance it on future versions of the model. And also here, because we don't have target and it's impossible to label it, to create this data set as we did to verify our hypothesis, it's important here to make some metrics to check if models still face our challenges, still address our problems. So it's a crucial part here. And now we can discuss a little bit about ML pipeline here. So what should we do after we solve like this cold start problem? So first step, it's like define the problem, and the cold start problem, it's like placed in this point. And after that, we do like data collection, exploratory data analysis, data preparation. So these points are mostly about cleanliness, about combine your features, about how you can use it in the future and where you can store them, the stuff like that. So it's about noise signals, it's also here. And the next step, it's like model selection and construction. So I think here, you know that here you can pick the model you like. For example, if it's like boosting or some network or some, I don't know, forest. And after that, it's important thing to think about model evaluation. And the crucial point here is about data leaks, because sometimes we see data differently, and it's really important to avoid data leaks during your model evaluation. And another important point here, it's about model optimization. So in my past, I had this problem when I built a really heavy model, and it was impossible to implement it into the current system, and it was quite upsetting. So when we talk about model optimization, it's really good to think about it before you make a research. So it's better to think if it's possible to optimize the model, or you need to think about different features, like which will be more light, so it's not so heavy to the app. And what else here? So we after that, we can think about model testing and deployment and monitoring. It's also a crucial part here, because in ideal world, it's really the best case. It's when you can leave your model and it will be alive without your supervision. So you can leave the company and the model will be still alive. And to do so, it's better to design, to create some monitoring dashboards or tests to be sure that the model is working. And without it, it's really difficult to change the model. And also here, you can put some documentation for others to understand your model. And the last part, it's about feedback and improvement, because, you know, sometimes it's easier to build a solution, a simple solution at first. So it's on the first step, you can build only simple solution, for example, some simple boosting of even a tree. But after some time, you can add some data which could help you to change a model to something like big and mature. So it's better to think about ways you can improve your model. Maybe you can add some features, maybe you can add some target, and maybe you can change it based on your feedback and stuff like that. So yeah, it's also really a crucial point here in the ML pipeline. And on the other slide, I would like to talk about some resources which can help you in your models. So it's like open source resources, and maybe if you have some pet projects or maybe even you can use these resources on your job, you can use that. So first one is like Yandex Taloka. So it's a resource with assessors which can mark some tasks as good or bad. And there is like other resources. It's like Labelbox and Scale AI, and it mostly can help you to add some target to your database when we talk about like computer vision, about some images. The next thing, it's like Hugging Face and Google AutoML. In these resources, you can find pre-trained network. So it's like online pre-trained network, and you can download it and use it on your projects. And what can we see after that? It's like word stats. So it's not really about ML. It's mostly about like statistics. So it's free informational service where you can generate some hypotheses about demand, for example. So it's an informational service where you can find some statistics based on search requests in time. So it could help you to build some hypotheses. And what else? So we can, you can send me some questions, or we can, I have several mistakes that I wanted to discuss with you that happened to me or happened to my colleagues, and it's interesting. So yeah, let's discuss that. And after that, we can go to some discussion, and maybe you can give me some questions and I can answer to some questions. So yeah, now I would like to talk about some mistakes I made or my colleague made. So the first mistake, it's like uplift mistake. Do you know what is like uplift modeling? So I will give you an example. And I think it's a best example why it's really important to think about uplift when you build a model. So what happened on these mistakes? It's not my mistakes, it's mistake from one of my colleagues. So what happened? We created a model to sell for selling TVs, and they gave people bonuses for buying. And they looked at the results on the control and test data sets, and revenue dropped sharply. So what happened? They built a model, a binary model. And that binary model were based on the target if a person tend to buy a TV or not. So the model had like great accuracy here because like magnificent model, but because in the result of this model, they just gave people some bonuses and some discounts. They give it to the people who would buy this TV even without the communication. So because of that, they just made the price of TV, so the price of the product lower. And in the result, the revenue dropped. So in these cases, it was like a really bad scenario to pick people who would buy a TV. So instead of that, we needed to find the people who would buy TV only with communication and only with discount. So this is this is an example of uplift modeling here, and it shows why it's important to make a good hypothesis before you implement the model, because the model was great, but still the result wasn't so great here. So another mistake, it's like, as I told you before, it was a mistake based on like optimization problem. So it was my mistake. I made it personally. So I created a complex model and implemented into this model into the application, and the application crashed because the application was unable to calculate features for scoring codes in real time. So yeah, sometimes you can change your features a little bit, but it was impossible on that app. For example, you can, if you try to gather the features from the past, sometimes it's really difficult to up or to gather this information, and it's really important to it's really important to think about it before you build a model. So if the system allows you to implement your solution, because sometimes there's some restriction in the system. For example, I tried to implement my model to our internal surfaces, and they have some limitation about seconds. And I didn't know about this restriction before. And they had like this restriction that the scoring code should be not longer than some seconds, because it's like a dashboard. And this dashboard has a lot of different models inside, and you need to see all these models on the same time. So they have like some restrictions and limitations in this interface. And during half of a year, we tried to make the model lighter. And I think it's a mistake. So the better way will be to think about these restrictions before, and maybe to design it lighter on the first steps. So this mistake about optimization. And the last mistake I wanted to discuss is about production and testing systems. So it's like common mistakes. Everybody makes it all the time. So it's about you created a model, implemented it in production system, made a mistake with a file, or made a mistake with some hypothesis, and you lost money. So it's okay to make mistakes. So the easiest way to avoid mistakes is to do nothing. So I don't think that it's important to try and to avoid mistakes, but the good case is to design a system which will make it impossible to make some visible mistakes, which can bring to money loss. But still, if you made some these mistakes, so most commonly the next step will be, so the first step will be to fix this mistake, and the next step will be how to create a system which will help you to avoid these mistakes in the future, like help so it's impossible to think about all possibilities which can lead to these mistakes. For example, it's based on my work experience also. So we built a system which was based on the logs table of people from other department, and they changed a feature without saying a word. So because of that, our system was dropped, and we didn't see it because it dropped the way we never saw that there are some changes. And after our process start to crash, we found out that they changed this feature. So but we had like some protection system inside this process, that in case it sees that it's some anomalies inside the system, it stop implement this anomalies in production system. So it really helped us because like it was impossible to know that our division will make some changes. So I think that's all I wanted to tell you. So maybe you have some questions here so that I can answer. You can send it to the chat. So in which cases do you think generated synthetic data is justified, and how do you validate its reliability? So I think mostly, in my opinion, the main point when you're trying to generate your data, it's like good for when we talk about computer vision. So when we talk about computer vision and when we talk about some text, it's really a cool way to generate some data because they have like profound systems, which really good like in shifting objects, in generated synthetic objects and stuff like that. And how can you validate it? You can use the majority of data. So you have your real target and you have your synthetic target. And the best way is to put as much real target as you can to put it to testify your hypothesis. And if you have like good synthetic data, you can use it in fitting in training part of your model. So so how do you decide whether to improve an existing model or build a new one from scratch? If we talk about pipeline here, like ML pipeline, thank you for your question. So, and I hope I answered like previous question. So if not, please text it on the chat also. So yeah, in the ML pipeline, we have here like the part with monitoring, and you on the monitoring, it shows you the health of your model in this process. And sometimes you can see that metrics, they are not so accurate, or you have some complaints, so you have a feedback that your model isn't good enough. And when you see these metrics, but it's not, and it's still good, but it's not so good as it was in the past, you try to change your model. Or for example, based on the practice also, sometimes some signal as a feature that was used in the model, it's not working any longer. So you don't have that kind of data and you need to put it out from your model. So in this case, you also need to improve your old approach or somebody else old approach. Or you just know that, like, for example, robots are evolving. So you need to find new robotic traffic. And in this case, you're trying to adapt your own model also. Yeah, and when you have a new problem, a new task, when you try to implement new solution, for example, so you have new targets, so it's impossible to change some old models, you build a new one. I never saw really an example when you had like previous versions of model and you just cancel it and tell like, okay, I will build a new model without information about this old previous model. So mostly the old decision, they're still working, but like not so good. So which metrics do you recommend for evaluating model quality in cold start scenarios where data is very limited? So as I told before, in my experience, we try to if we still have data, but it's limited, but we still have them, we can, based on this data, build some metrics about the quality of the model and keep as much labeled target as we can on our testing data set without our communication. And if we talk about situation where we don't really have any targets, so you can make some surveys, for example, you can ask a feedback, and based on this feedback, you can make some decisions about your model, or you can have some correlated signals. For example, if we talk about traffic quality problem we discussed previously, you can make some correlation boards of each metrics based on the score. So the main guess here will be that on the bottom of the score, there will be like pages with real bad other metrics, like not this one, but the metrics based on which was fundamental to the our score, our quality metric. Hello, Alim. Have you applied the Elkanot method in a real world project? What were the challenges? Yeah. So about Elkanot method. Yeah, I tried to apply it in real world project, and basically I don't believe in this method without this. So it could work without this split of features on the first iterative model and second iterative model, but I think that I implemented it with this split. So it was kind of we built it kind of outer ML baseline, and we used this approach to add some information about dataset, and we basically built it something like some API in which you can give some any target, and we had like one set of features to predict the possibility of label target in the data set, and then we had another set of features to build a model. So yeah, we used it, but mostly to the baseline model. So I think when we talk about creating a model, you can use it as a baseline, but maybe you can correctify it a little bit, so not use it as it on the paper. So how you define criteria for detecting financial statement fraud when you don't have clear target labels? So I'm not sure about this question, if I understand this question correctly. As I understand it, it's about features, or it's about, we had targets. So in like fraud in financial statement, we had target, but it still was really few observations there. So it was, as I remember, less than 200 observation there. So it's not really a lot of observation through time. So it's like the period was 2 years, and we had extra information about this company. So we had information about transaction, we had information about our inner credibility rating, we had information about some complaints, we have information about like generic information about like the size of the company and stuff like that. And we saved this real target to verify our model, and we built a model based on like these different correlated signals. So we find out a signal which really correlated to our target data, and we saw that the target, so almost always, so not almost always, the companies which target rating dropped drastically and suddenly, they have like periods of time when they recheck their rating, the credibility rating, and when it drops drastically, in the result, all companies with fraud in their financial statement, they had this like drastic drop because like it's really correlated with credibility. So we built a model based on this signal, different signals. So not all the company with this drop in the end, they had some frauds in their behavior, but still it was really strange, this drastic drop. So sometimes it can be some natural causes, but still really strange signal. And we used this signal to build a model, and we scored companies, and companies with high score, they were high probability that all companies which have some frauds in their like statements will be in this cluster. Yeah, and we checked it in the survey. So we checked it with the help of our colleagues who checked the statement by ICE. So what lessons did you learn from uplift model in case with revenue dropped? What steps would you recommend to avoid mistake when moving models from test to production? So I think the first question was about uplift here. So yeah, so our main, it's really important when we talk about giving people money. So about giving them bonuses or giving them discounts, it's like you need to know which people you want to gather. So yeah, when you give people money, you need to be really accurate here, because you don't want to touch audience which would make some action without your communication and without this bonus. And so in this case, I think that the whole hypothesis, like initial hypothesis, it was wrong, because you don't need to find a person with a high probability of buying TV. You need to find person which has high probability of buying TV with your communication, but has low probability of buying TV without your communication, or not so high probability of buying TV. So you need to change the approach here, and you need to be really accurate when we talk about giving people money. Also, when we talk about this loyal system, about bonuses, there's some fraud in bonuses also. So you have a lot of people who trying to make advantage of the bonuses, of discount, of the discount. They have chats, and the good way is to try to detect those people before you implement a model, and avoid communication with them. Yeah. And what steps would you recommend to avoid mistakes when moving models from test to production? Basically, when you have this like test control, so in some companies, you already have like this system when you have like test counter and prod counter, and you need to just make some tests to see if like the revenue is okay, if like hits are okay, if there is no anomalies. But the good way is to build two tables, two data sets, or without your model and with your model, and to check if like nothing happening. So if we talk about, for example, if we talk about the system which will reduce some traffic based on the decision of the model, you can, on the same day, you create two processes, like old way of processing the whole like traffic data, and new day based on your model, and compare one to another. And the resulted you see, it should be you can explain it. So the hypothesis should be correct there. So the drop should be the one you agreed on. And you can basically, it's based on your metrics inside your company, for example. So in my company, it's based on revenue mostly, because people don't like to lose money a lot. And because of that, you will measure that metrics, which matters. And it's better to implement some mechanics which will stop your system of using this new database or new solution if there is some anomalies. For example, if you try to cancel half of the traffic, it's better way that you couldn't do it. Like the system will go on the previous approach, not on your new approach here. So have you used tools like Google AutoML or Yandex.Toloka for rapid model development? What were the pros and cons? So personally, I never used these kinds of models, but because I'm not working with computer vision, but my peers who works with computer vision often use this type of instrument. And I never used by myself Yandex.Toloka because we have like inner instruments of assessors. So we have some inner solutions, and this solution helps us to build models mostly. So I never used like this instrument, but I used like models from my peers, like from my colleagues. I used pre-trained models from my colleagues. So which pros and cons? When you have some anomalies, it could be based not on your model, it could be based on another model, so stuff like that. But when you have like your colleagues, you can ask them about flaws in the models, and it's better to look on score, look on distribution when you use other models, and to look on some healthy scores like accuracy, precision, recall, stuff like that. So do you have any questions? Any other questions here? Thanks. Thank you. Thank you, Ekaterina. Thank you, Leonid.
Thank you, Olga. I think we can finish.
Yeah.
Thank you for your lecture. And thank you to all our audience. It was great. Hope we will see you again someday in Silicon Valley.